Hi everyone, this is Dr. GVR Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So today in this session, we will discuss about Model Paper 1 questions related to hydrodynamic lubrication, and we will see one numerical problem. So the Model Paper 1 questions and answers. So the problem is here, determine the viscosity of the lubricant in centipoise have viscosity 160 SUS. It means Sebald universal viscosity, that is units. And the specific gravity, the universal value, that is convert, you have to convert into SUS to SUV. Then the specific gravity is 0.86. The step-by-step conversion here shown, the convert SUS to Sebald universal viscosity, SUV. The Sebald universal viscosity in seconds is numerically equal to the SUS value. So the convert SUS to centistone, CST. For fluids with SUS values greater than 100, the approximate conversion formula from SUS to centistone is shown here, VCST. That is equal to 0.226 minus, multiply with 160 minus 190 by 160. So now here the actual formula is VCST. So VCST means here shown the SUS to centistone. So whenever the fluids with SUS value is greater than 100, so 0.226 multiply with SUS value minus 190 by the SUS. So how much given SUS here? 160. So substitute those value and then calculate this value 190 by SUS value 160. The stoke value is equal to 36.16 minus 1.21975. That is equal to 34.94125. So convert centistokes to centipoise. So the relationship between centistokes and centipoise involves the specific gravity. SG is equal to theta into Cp is equal to BCST into SG. Where here theta Cp is the viscosity in centipoise, BCST is the kinematic viscosity in centistokes, and SG is the specific gravity. Now substitute in this relationship. Already we have calculated 34.9415 in previous step. Substitute the VCST value in this equation and calculate. So the final Viscosity of the lubricant is approximately, we'll get 30.05 centipoise. Next question is explain the importance of hydrodynamic lubrication in tribological applications. So the importance of hydrodynamic lubrication plays a plays a crucial role in tribological applications, which involves the study of friction, wear, and lubrication of interacting surfaces and relative motion. So actually, the tribology subject involves these three only: friction, wear, and lubrication. So that's why the hydrodynamic lubrication it plays very important role. So the hydrodynamic lubrication HL occurs when a full fluid film completely separates the moving surfaces, so preventing direct contact. So in this hydrodynamic lubrication, there is no metal to metal contact. So whenever present the metal to metal contact, there is a wear and there is a friction. To avoid this metal to metal contact, you should use this hydrodynamic lubrication system. So it prevents the direct contact. This type of lubrication is achieved when the lubricant film thickness is significantly greater than the surface roughness of the interacting surfaces. So the film thickness is must greater than the surface roughness of the interacting surfaces. The importance in tribological applications: reduction of friction, so primary function and energy efficiency. So hydrodynamic lubrication minimizes friction between moving parts by creating a continuous fluid film. This reduces the energy losses and increases the efficiency of mechanical systems. So the energy efficiency: lower friction translates into reduced power consumption in machinery, leading to energy savings and cost reduction. Next, minimization of wear. Surface protection, component longevity, that is the life of the component. So the by preventing the direct contact between surfaces, HL significantly reduces wear and extend the life of components. So the component longevity, this is critical in applications where replacement or repair is costly, such as in engines, turbines, and industrial machinery. So next, heat dissipation, cooling effect, and thermal management. The lubricant in hydrodynamic lubrication acts as a coolant, the absorbing and dissipating the heat generated due to friction. So thermal management: effective heat dissipation prevents overheating, maintaining optimal operating temperatures, and protecting components from thermal damage. So whenever the heat dissipation is equal to the heat generated, or heat dissipation is greater than the heat generated, so that is uh, not possible, but sometimes they may be occurred. So whenever the dissipation is capacity is less than the heat generated, that is the serious problem. Have to use the extra cooling requirements. So the artificial cooling systems you have to arrange. So whenever the dissipating capacity heat generated due to the friction, the heat dissipated to the surroundings, the component will not be fail. So thermal management effective heat dissipation prevents overheating, maintaining optimal operating temperatures and protecting components from thermal damage. So whenever more heat is generated, there is a chances of component fail. That is called as thermal damage. So the thermal management means the effective heat dissipation prevents the overheating. So maintaining optimal operating temperatures is required. Load carrying capacity. In this, bearing support, the hydrodynamic lubrication allows bearings and other components to support heavy loads without surface damage. The lubricant film evenly distributes the load across the contact area. The structural integrity. This load distribution helps maintain the structural integrity and the performance of the machinery. So the loading carrying capacity. So one is the based on the bearing support and the structural integrity. So vibration noise reduction, damping properties, and operational smoothness. So the fluid film in a hydrodynamic lubrication acts as a cushioning effect, that is damping vibrations and reducing noise generated by the interaction of moving parts. So whenever two parts are interacting with each other, there will be chance of a noise generation due to the vibrations. So this fluid film act as a cushion and also reduces the noise and vibrations. Reduce the vibration, ultimately it leads to reduce the noise. The operational smoothness, this results in smoother operation and less mechanical stress on the components. So contaminant exclusion, barrier function, clean operation. The continuous lubricant film acts as a barrier, preventing contaminants such as dust, dirt, and debris from reaching the contact surfaces. Clean operation means this helps maintain clean surfaces, reducing the risk of abrasive wear and corrosion. That's the consistency and reliability. Stable performance. The hydrodynamic lubrication provides consistent and reliable lubrication over a wide range of operating conditions, including varying speeds and loads. So the predictable behavior. This predictability is essential for designing a reliable and robust machinery. So next applications are hydrodynamic lubrication is essential in various industries and applications including automotive and aerospace, in engines, gearbox and turbines where efficient and reliable operation is critical. Industrial machinery in bearings, pumps, compressors and other rotating equipment. The marine and offshore, so in propeller shafts, bearings and other marine machinery components. The manufacturing area in machine tools, rolling mills and other equipment where precision and longevity are required. Where the precision and long life is required, there this hydrodynamic lubrication is essential. So in industries, automotive and aerospace, industry machinery, industrial machinery, marine and offshore and manufacturing sectors. So next question is discuss briefly about lubrication regimes and its importance. So what are the regimes in boundary lubrication? So it occurs when the lubricant film is so thin that the surface roughness fakes of the interacting surface come into direct contact. So their importance is essential in conditions where aerodynamic films cannot form, such as during a startup, shutdown, or low speed operations. The additives in lubricants like anti-wear and extreme pressure additives play a crucial role in preventing excessive wear and damage. So the applications are gear teeth, cams, and slow speed bearings. Mixed lubrication. So this type of mixed lubrication occurs when the lubrication designs is between boundary and aerodynamic. So both surface asperities and a partially formed lubricant film support the load. The importance is the transitional and often occurs during changes in operating conditions, such as speed or load. The proper lubricant selection and formulation can enhance performance by reducing wear and friction. The applications are medium speed machinery, varying load conditions. So wherever the varying load are there, and then machinery speed, medium speed machinery, this is suitable the mixture lubrication. So aerodynamic lubrication already we have studied in the previous we have learned in the previous slide, provides a lowest friction and wear and ensuring smooth and efficient operation of machinery, essential for a high speed and high load applications. So the general bearing, high speed shafts and turbines applications. So these are the references I have taken for this questions. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.